Hello Year 11 and welcome to our 7th video here for further graphs. Okay, we looked at absolute values in the last video, number 6, and we're going to look at some more slightly complicated ones today. So we're going to start with absolute values, and these aren't graphs to begin with. Okay, we're just going to talk about solving absolute value equations, or inequalities. Right, equations and inequalities. With absolute values, we produce two solutions. There are two possible solutions. One where what's inside the brackets is positive, and one where what's inside the brackets is negative. Right? So what absolute value does is really give us the magnitude, how far away it is from 0 on the number line, whether to the left or the right. So in this case here, which is almost a trivial solution, we consider x equals 5 or x equals negative 5. They're two solutions. Over here, I'm going to say 2x minus 1 equals 4 or 2x minus 1 equals negative 4. Then I'm going to add 1 to both sides. I'm going to divide both sides by 2. And that leaves me with solutions x equals 2.5 or x equals negative 1.5. Right, if I substitute either of those numbers into this expression, I end up with 4. Now, moving along. Absolute value inequations. What's going to happen? Because we get two solutions, I sort of either get the outside bits or the inside bits. I either get x sandwiched between two values, or I find x is less than the small number and greater than the big number. If it is, my absolute value is greater than something, then I'm on the outside of those things. It has a bigger magnitude. If my absolute value is less than something, then it's between two values. But nonetheless, we can arrive at those solutions remembering those things or otherwise. So here we go. I want to solve this, and I consider the two cases. So 8 minus a half x is greater than or equal to 3, or 8 minus a half x is less than or equal to negative 3. Now I have to change the sign here when I consider that negative case. Now, solving that, we're going to subtract 8 from both sides, from every side. We're going to multiply everything by negative 2, and multiplying by negative, to get rid of that fraction, is going to change the direction of the signs. So that gives me these two solutions here. X is less than or equal to 10, or x is greater than or equal to 22. On a number line, looks like this. Less than 10, greater than 22. Here's another example. 3x plus 7, absolute value, is less than 3. Now, less than means it's going to be sandwiched between two numbers. But nonetheless, I'm still going to work it out as two separate parts. Okay, so 3x plus 7 is less than 3, or 3x plus 7 is, change the direction, greater than negative 3. Subtract 7 from both sides, divide both sides by 3, and I find that x is less than negative 1 1/3, or greater than negative 3 1/3. Now, the reason I've used these mixed numbers that we don't use terribly often in maths anymore is because when we're graphing things on a number line, improper fractions requires a little bit more thinking. But we can see here on my number line, well, here we go, that's my combined solution, that x is less than negative 1 1/3, but greater than negative 3 1/3. So it occupies this range in here. Okay, pushing along. Polynomial inequalities. How do we do these? Well, we find the roots to find the boundary values, and we might draw a sketch if we can, or we might draw up a table of signs. I'm just going to use a table of values and determine the signs from those. I'll show you what I mean. So here we go. I have a polynomial function here, and I've been given the equation, which really makes life pretty easy. Well, the equation is one thing, but to have the graph here, well, if this is the graph of the function, when is it greater than or equal to 0? Between negative 2 and 0, and when it's more than 1. Right, so straight away, that's it. X is between negative 2 and 0, equal to, and x is greater than or equal to 1. Now, if I just had the equation, I know I've got roots at 0, negative 2, and 1. 0, -2 and 1. And I suppose, thinking about our polynomials, I can see that my leading coefficient will be a positive number, will be 1. Right? The x cubed term will be positive. So it sort of goes from third quadrant to first quadrant kind of thing. Right? Moves up there. And I should be able to infer from that where it's positive and negative probably. But a sketch is always helpful. Here, slightly more complicated function, and we're lucky to have the graph again. So it's a little interesting this time. When is my function greater than or equal to 0? Everywhere between -2 and 1. It's equal to 0 here, but it doesn't cross over. Right? There's nowhere between -2 and 1 where my function is negative. So, simple answer, x is between -2 and 1. Okay, now a couple of examples where we don't have the graph. X cubed minus, x to the power of 4 minus x squared is greater than or equal to 0. We'll factorize that. We'll let it equal 0 and factorize it. I get x squared outside of this, and that's perfect square, so it's x squared outside of x plus 1, x minus 1. Now, if I were to graph that, right, I'm going to get something that looks a bit like a W. But let's use a table of values here instead. I know I've got roots at 0, -1 and 1. So let's look at values less than -1, between -1 and 0, between 0 and 1, and greater than 1. Right, so they're my roots. We want to look at numbers that are between all of the roots and also beyond each of the roots. So I've chosen 2, -2, -half, half, and 2. They're pretty much the easiest numbers I could choose that weren't roots themselves. And I know that if I substitute 0, -1 or 1 into this function, it's equal to 0. Right? That's how we solved it. So those are the values I'm going to test. I substitute them in. So -2 to the power of 4 minus -2 squared is equal to 12. And if I substitute -half into this expression, I get -3/16. If I substitute positive 1/2 into that expression, I get a -3/16. And if I substitute 2 into that expression, I get 12. So positive, negative, negative, positive. So that tells me it's going to be positive anywhere below -1. And it's going to be positive anywhere greater than 1. Okay, to the right of my biggest number, to the left of my smallest number. And this thing will also be equal to 0 at 0, -1 and 1. So my solutions are x is less than or equal to -1. Right, remember that's positive. So that means anything up to and including -1 will be positive. At x equals 0, right, it's sort of a little island surrounded by negativity, right, and x is greater than or equal to 1. This is what the graph looks like. So you can see positive here is 0 at 1 and -1. And it also manages to be 0 there when x equals 0. And because I want greater than or equal to, right, I have to include that in my solution as well. Okay, so at this point, x equals 0, as well as less than -1 and greater than 1. It's our W shape that we mentioned. Okay, a little bit more. This one's not so hard, actually. It looks a bit complicated. However, there's a neat trick. What are we going to do here? Well, if I were to divide both sides by m cubed, I'd make life a lot more complicated. But there's a chance that m cubed is a negative number. But there's no chance that m squared is a negative number, because all squares are positive. So I divide both sides by m squared, and I don't have to worry about turning the inequality symbol around. Right? By doing that, I find that simply m is less than 4. It all cancels out. Right? I'm dividing by a positive number. I know it's positive because it's a square. So simply, m is less than 4. Nothing more to think about. Just to demonstrate what's going on here, I graphed these two functions, y equals x cubed and y equals 4x squared in decimals. And you can see that the cubic function, the black line, is below the red line, right, and it's strictly less than, not equal to, is below the red line everywhere to the left of, or everywhere smaller than x equals 4. That's where they intersect, right, x equals 4. And that's what I was after, m is less than 4. Right, it's where this graph is below this graph. Righto, that's it. Oh, I don't even have a coming up next. That's it. If you've got any questions, make sure that you jot them down, ask me in class. Other than that, I will see you in our next video. Thanks, Year 11.